You know that you can compare alpha with the associated p-value in order to make a decision about the null hypothesis. Another way to measure statistical significance and test the null hypothesis is to compute a test statistic. Two common reference distributions for statistical hypothesis testing are the t-distribution and the f-distribution. A reference distribution enables you to quantify the probability of observing a particular outcome, the calculated sample statistic, or a more extreme outcome if the null hypothesis is true. That probability is the p-value you're already familiar with. The t-distribution and f-distribution are characterized by the degrees of freedom associated with your data. Depending on the type of analysis you're performing, you'd use your data to calculate a sample t-statistic or a sample f-statistic and compare that statistic to the reference distribution. Values that fall in the tails of the distribution are values that are possible under the null hypothesis, but unlikely. The t-distribution arises when you are making inferences about a population mean and, as in nearly all practical statistical work, the population standard deviation, and therefore standard error, is unknown and has to be estimated from the data. It is approximately normal as the sample size grows larger. The t-statistic measures how far x bar, the sample mean, is from the hypothesized mean, mu sub 0. It is the number of standard errors that the sample mean is from the hypothesized mean. The formula is shown here. The t-statistic is positive when the sample mean is larger than the hypothesized mean, or negative when the sample mean is less than the hypothesized mean. If the t-statistic is much higher or lower than 0 and has a small corresponding p-value, this indicates that the sample mean is quite different from the hypothesized mean, and you would reject the null hypothesis. You use the t-statistic when you don't know the true population standard deviation, sigma, and you only have an estimated standard deviation, s. This graph shows the t-critical region in relation to the t-distribution. If the t-statistic and corresponding p-value fall in the critical region, the shaded region on the graph, then you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. The area in each of the tails corresponds to alpha divided by 2, or 2.5%. The sum of the areas under the tails is 5%, which is alpha. Because the rejection region for the t-statistic is contained in both tails of the data distribution, statisticians refer to this type of hypothesis test as a two-sided t-test. If the data comes from a normal population, then the t-statistic calculated from the data follows a t-distribution, and we can use the t-distribution to compute p-values. The t-distribution is a symmetric distribution like the normal distribution, except that the t-distribution has thicker tails than a normal distribution. If the data does not come from a normal distribution, then the t-statistic approximately follows a t-distribution as long as the sample size is large, and we can still use the t-distribution to calculate a p-value. This is another application of the central limit theorem.